Hello students, we are discussing the transmission phenomena, that is the transmission from one fluid to another in a normal incidence mode, and we are reached to the expression of finding the value of V1 in terms of A1, okay, and we have discussed different conditions as far as when will this B1, okay, will be real positive or negative, or how will we get the standing wave ratio, where we'll find the antinode or where we'll find the node, what are the conditions. So everything is understood. So now we'll move towards defining the intensity I of the plane wave. Okay, so how do you define this intensity? So intensity of a plane wave is basically given by the expression P square divided by 2 rho 0 C. Now we know very clearly that the value of rho 0 C or the value of rho 0 C is different for air and water, and rho 0 C is basically my characteristic impedance. Fine. Now I mentioned when we began this topic that our aim is basically to define the ratio of reflected flow of sound energy to the incident flow of the sound energy. This is the incident wave, this is the reflected wave. Fine. So the ratio of reflected flow of sound energy, okay, to the incident flow of sound energy is basically defined by alpha r. So what is alpha r? Alpha r is nothing but IR. IR is intensity of the reflected wave divided by intensity of the incident wave. So in case of IR, what is the amplitude term we got? We have got B1 square divided by real A1 square. That's what expression I told you earlier. So B1 was rho 2 C2 minus rho 1 C1 upon rho 2 C2 plus rho 1 C. Fine. So substitute the value over here. So we will get the value rho 2 C2 minus rho 1 C1 divided by rho 2 C2 plus rho 1 C1 bracket square, because this is B1 upon A1 bracket square. Fine. So this is my expression number, I think 11, because this was my equation number 10, where I got the value of A1 plus B1 bracket square and A1 minus B1 bracket square, where we had dealing with the cos square and sin square terms over here. Okay. Now further, so I mentioned that alpha r is basically what? This is my sound power reflection coefficient. Okay. Now what we'll do, we'll try and use the earlier equation. Okay. The equations what we have got earlier, where I'll repeat it again. Equation I wrote was A1 plus B1 is equal to A2. Check equation number from your notes. This we discussed earlier already. Okay, fine. Now we had one more equation, even that I'll write, and that you must be definitely knowing, which is rho 2 C2 A1 minus B1 is equal to rho 1 C1 A2. This we got the equation over here. Rho 2 C2 A1 minus B1 is equal to rho 2 C2 rho 1 C1 A2. Fine. So this equation I am trying to talk about. So this itself helped us to get the value of B1 to A1. Okay. Now my aim is, I got B1 to A1. Now my job is to get A2 and A1. A2 in terms of A1. Okay. Now to get that A2 in terms of A1, what I had to eliminate? I had to eliminate B1. Last time what we did, we eliminated A2 because I wanted B1 in terms of A1. Agreed? That's why we got this value B1 upon A1. Now I have to eliminate B1. So what will I do? I have substituted the value of B1 from this equation itself. What is B1 now? A2 minus A1. This implies B1 is equal to complex A2 minus real A1. Put the value over here and simplify. So what I'll get? Rho 2 C2 A1 minus B1 value is how much? Rho 2 C2 we have to multiply obviously. So I'll first substitute the B1 value. So B1 is A2 minus A1 bracket complete is equal to rho 1 C1 A2. Okay, now simplify. So we'll get rho 2 C2 A1 fine minus rho 2 C2 A2 minus plus rho 2 C2 A1 okay is equal to rho 1 C1 A2. Okay, so after doing this equation, what is our next job? Simplify further. So this is what rho 2 C2 A1, this is rho 2 C2 A1, so this will become twice and this A2 term will go on this side. So I'll write it first. So this is twice rho 2 C2 A1. So this term and this term is done. This term goes over here. So what will I write over there? I'll write rho 1 C1 A2 and this term will go here, will become plus rho 2 C2 A2. So this is nothing but twice rho 2 C2 is equal to. Okay? So now what will I say? I'll say twice rho 2 C2 A1 is equal to A2 is common and inside the bracket rho 1 C1 plus rho 2 C2. Fine. So I need the ratio. So what will I say? Therefore A2 is equal to twice rho 2 C2 A1 divided by rho 2 C2 plus rho 1 C1. I wrote this term first, then this term because of to match with this. Already there is a plus sign, so there is not much problem as far as I write this term first or I write this term first. So this is my expression for A2 in terms of A1 because I eliminated the value of B1, eliminate B1, so it was easy for me to get A2 in terms of A1. Fine. Okay, now after doing this, like I defined here alpha r, my job is to define now alpha t. Alpha r as what? Alpha r was sound power reflection coefficient. Same way, I will define now the sound power transmission coefficient will be called as alpha t. Now what is alpha t? In the same fashion, this was IR by II. So this should be IT divided by II. Now what is IT? The intensity of the transmitted wave divided by intensity of the incident wave. Okay. Now what is my IT with this formula or with the normal formula like I told you earlier? So here I can write as far as IT is concerned, I can say A2 square divided by twice rho 2 C2. Rho 2 C2 is characteristic impedance for the medium 2 divided by A1 square, A1 is normal real A1 divided by twice rho 1 C1. Fine. So A2 for the medium 2 where there is a transmitted wave, that is this part, transmitted wave, and the incident wave will be II. So here if at all I cancel the 2, what will I get the expression as? I will get the expression as rho 1 C1 divided by rho 2 C2 into A2 square divided by A1 square. This is my expression. Okay, this is the expression for alpha t. Like here I had the alpha r expression, rho 2 C2 minus rho 1 C1 upon rho 2 C2 plus rho 1 C1. In this fashion we'll have expression for alpha t also. So what will I write? This is twice. Okay, so I'll write the expression for A2 upon A1 from this. Now what is A2 upon A1 bracket square? That will try and write now. So what we'll say? This is my equation number 12. This is 30. So now we will say alpha t is equal to rho 1 C1 upon rho 2 C2 and this A2 upon A1 bracket square term will come from this. So I'll write alpha t is equal to, as I mentioned, write rho 1 C1 divided by rho 2 C2 as it is, multiplied by what I said, A2 upon A1 bracket square. So that should be twice rho 2 C2, okay, I'll write first 2 rho 2 C2 divided by rho 2 C2 plus rho 1 C1, correct? This is the value. I'll cut this and write properly 2 bracket square. Understood? This is A2 by A1 bracket square twice rho 2 C2 divided by rho 2 C2 plus rho 1 C1 bracket square. Okay, so if you simplify this, what will I get? This is 2 square will be 4, correct? Rho 2 C2 square, okay, multiplied by rho 1 C1, this term, divided by rho 2 C2 into rho 2 C2 plus rho 1 C1 bracket square. So one part goes cancelled and we have 4 times rho 2 C2 rho 1 C1 divided by rho 2 C2 plus rho 1 C1 bracket square. This is the value of alpha t. 4 times rho 2 C2 rho 1 C1 upon rho 2 C2 plus rho 1 C1 bracket square. This is the expression of sound power transmission coefficient. Okay. Now suppose we know the value of rho 1 C1 air. What is the value of rho 1 C1 air? I told you, which is 415 Rayleigh, RAYL. Similarly, what is the value of rho 2 C2 water? What I am using, I mean this is my boundary, this is air obviously with characteristic impedance rho 1 C1, here it is a water, characteristic impedance rho 2 C2. So that I am talking about. So that's why I am saying rho 1 C1 air is 415 Rayleigh, rho 2 C2 for the water will be 1480000. Okay. Now with this formula, I want to find out the value of alpha t. How will I do? Alpha t is equal to 4 times. How much is rho 2 C2? And then rho 1 C1. Rho 2 C2 is 14800 3 zeros into 415 divided by rho 2 C2 is 14800 3 zeros plus 415 bracket square. So if you simplify this, okay, the answer will turn out to be 0.00112. This is the expression for alpha t. Okay, I forgot to put the expression number. So this was my 13. So this should be my equation number 14. Okay, and now suppose we got the value of alpha t to be 0.00112. So what we can say, that the intensity of a plane wave, okay, intensity of the plane wave passing at normal incidence, either from water to air or from air to water, is reduced by a factor of 0.00112. Okay, this will correspond to a decrease in intensity level, and that decrease in intensity level is given by 10 log of alpha t to the base 10. So in this case I know the value of alpha t, so put the value there. So I'll get log to the base 10 of 0.00112. Okay, so if you see the log of this, multiply by that 10, the answer will be minus 29.5 dB. So this is my intensity level, this is my alpha t. So what I said, the intensity, as I'll again repeat it, this is my boundary, okay, this is medium 1, this is medium 2. So what I said, the intensity, the plane wave is coming and hitting, by which you get a reflected wave and a transmitted wave. Fine. So the medium 1 can be either air or water, medium 2 also can be air or water. Okay, so we have seen all the conditions. Rho 1 C1 is greater than rho 2 C2, rho 1 C1 is equal to rho 2 C2, and vice versa. So now the intensity of a plane wave passing at normal incidence either from water to air or from air to water, okay, is reduced by a factor of 0.00112. This corresponds to basically what? A decrease in the intensity level by which formula? This formula, 10 log alpha t to the base 10. So you get 10 log to the base 10 of the value of alpha t. So you get the value of IL to be minus 29.5 dB. Correct? So in this case, what we have proved? We have proved the first, we have seen basic equations. Then we got the value of B1 in terms of A1. Then we got the value of A2 in terms of A1. A1 will be always over here because A1 is incident wave. This is for the reflected wave. And just now what I got, that was for the transmitted wave. A2 by A1 means transmitted by incident. And this was reflected by the incident. Okay. So I think this should be very, very clear in your head as far as what we are trying to prove over here. Correct? So after completing this, I'll just take one simple problem. Okay. So the first problem will be, suppose I say that I have the relation alpha r and alpha t. I mentioned you alpha r is my sound power reflection coefficient and this is sound power transmission coefficient. Now the relation between alpha r and alpha t is what? Alpha t is always 1 minus alpha r. This is the relation between both. Okay. Now we know the value of alpha r and alpha t both. So just substitute the value of alpha r and check, do you get the same answer what we got it over here just now? We know the value of alpha t, what do you got? This formula, correct? So we'll try and substitute the value of alpha r. What is alpha r value I taught you? Alpha r value is rho 2 c2 minus rho 1 c1 bracket square divided by rho 2 c2 plus rho 1 c1 bracket square. Fine. So if at all I take a LCM and simplify this further, so what will be over here? Rho 2 c2 plus rho 1 c1 bracket square, and this will be rho 2 c2 plus rho 1 c1 bracket square minus rho 2 c2 minus rho 1 c1 bracket square. Fine. Now simplify a plus b bracket square, a minus b bracket square. So you get rho 2 c2 square plus twice rho 1 c1 rho 2 c2 plus rho 1 c1 bracket square. Fine. These three terms. Same way we'll have three terms here also. So this will be rho 2 c2 bracket square with a minus sign. Then middle term will be minus, but minus minus will become plus. Okay. Middle term will be minus. So this will become twice rho 1 c1 rho 2 c2, and the last term should be again square will be plus. So but this minus sign, so this will become minus. So rho 2 c2 rho 1 c1 bracket square, okay, divided by the denominator as it is, rho 2 c2 plus rho 1 c1 bracket square. So if we simplify, this is minus sign, so this gets cancelled, this gets cancelled. So what is left is 4 times rho 1 c1 rho 2 c2 divided by rho 2 c2 plus rho 1 c1 bracket square. So this is the way you got the same answer what we had derived earlier over here. What we derived earlier over here is this 4 times rho 2 c2 rho 1 c1 rho 2 c2 by rho 2 c2 plus rho 1 c1 bracket square. So which means the relation between alpha t and alpha r is true, that alpha t is nothing but 1 minus alpha r, or 1 minus the sound power reflection coefficient. That's what we have understood in today's lecture. Okay, so this ends our first little bigger topic from the module 1. Okay, similarly we have one more topic where instead of the boundary, we'll try and see that there is a solid surface and then observe what happens to the transmission phenomena. That is our, in short, the second topic. Okay, so go through it, check any difficulty you have it, feel free to ask me. Okay, thank you very much.